exponents, or where we're going to start. Really easy thing today. If I tell you to evaluate, what does that mean? Solve, get the answer, work out the number. That's what evaluate means. So if we had a problem like 2 to the third power, if we're going to evaluate that, what does it mean to have 2 to the third power? Yeah, 3 copies of 2 and multiply them together. 2 times 2 times 2 is 8. And you've evaluated that. Exponents, that's what it means to take something to the third power, multiply it times itself 3 times. If you had 3 to the fourth power, what's that mean? 3 times 3 times 3 times 3. And if you kind of take the same process, 3 times 3 is 9, times 3 is 27, but not too many of us know our 27th times tables, right? Or I don't, anyway. But if I did 3 times 3, that's 9. And then if I jump over here and do 3 times 3, that's 9. But then 9 times 9, most of us know our 9s times tables. 9 times 9 would be 81. So because it's multiplication, you don't have to do it in exactly the same order as it's written. You can kind of group it up a piece at a time if you want to. Okay. So evaluating just a number, getting that answer, this is called standard form. When you work out the number, it's standard form. If we leave it like this, when we do some other problems, this is called exponential form. 2 to the third power is exponential. 3 to the fourth is exponential. 8 is standard. 81 is standard. So exponential has exponents. That makes sense. Standard is just a regular number. Okay, so if I tell you to write your answer in exponential form, that means don't work out the number, just get the exponent part. If I tell you to write your answer in standard form, I mean, work out that number. What if it's 3 to the fifth power? Go ahead and give me that big number, whatever 3 to the fifth is. Okay, so that's what I'm kind of trying to get here, because they ask for different things. If I ask for exponential form, that's what exponential form looks like. Exponential. That's exponential form with an exponent. This is standard form. And there's going to be times where they're going to ask for an answer in standard form, or they're going to ask for an answer in exponential form. You got to know the difference in the two. Exponential has exponents. Standard does not. That's if it's a number. Okay. All right. Let's look at some properties of exponents. The first property we want to look at is a product. Product is what kind of math? Product is the answer to what kind of problem? Multiplication. Product of powers. And first thing we need to talk about is what the heck is a power? A power, yes, that's this. It has an exponent. What's the A called? The base. Okay, the base and an exponent. The entire problem is technically called a power, but the base and the exponent. Okay, it's important to recognize what the base is, because it is what allows you to do some of these properties. Okay, if the bases aren't the same, you can't follow the rules that are there. If the bases are the same, then there's some other things that can happen. Okay, so a product of powers would be something like this: a to the nth power times a to the n power. The bases are the same here, a and a. What does anybody remember the rule for the exponents there? Absolutely, you add them. Okay, so if it's multiplying and the bases are the same, you add the exponents. That's the rule that you want to key in on there. The bases are the same, add the exponents. Bases have to be the same to do that, though. Okay, so if you had something like this, x to the third times x to the fifth, real basic power problem. What's the base? X, and the new exponent would be x to the 8th. 5 plus 3 is 8. That's where that's coming from. Yes, the base, if you're multiplying and bases are the same, you add. Y times y to the fourth. It was a little bit different because they don't have the exponent written on that first y. If there's not one there, it's a 1. There's a 1 exponent right there on that y. So it ends up being y to the 5th power. What's the base for this problem? -5. Notice that it's in parentheses. That's important because that's saying, okay, -5 is raised to the 3rd power. -5 is raised to the 4th power. Those parentheses are going to be important when you start looking at these problems. So that means these parentheses need to be here when I write my answer with the base of -5. Base of -5, what's the exponent on the answer? 7. So 4 plus 3 is 7. So mathematically, this is not hard stuff. You just got to pay attention to what's going on. This is where folks kind of run into a little bit of an issue, is when you have a problem that looks very similar, but is not the same. The key to this one, the difference in example E and example F. This one has the parentheses around the -5. This one has no parentheses there. And it's only got the negative in the front there. So what's the base in this problem? In example F. Is it -5 or +5? Well, this one's only one negative and that one's not. Here's the thing with this, and it stems back to order of operations. That in order of operations, exponents, it comes right after parentheses, okay? And the exponent is on the 5, not the negative. This problem is really -1 times 5 to the 3rd times 5 to the 8th. That's really what this turns into. -5 to the 3rd. It's like negative and then 5 to the 3rd is what that's saying, okay? And then, so it's like a -1 hanging out in the front, and then 5 to the 3rd, and then 5 to the 8th. Well, that makes this part easier. Because what does 5 to the 3rd and 5 to the 8th end up being? 5 to the 11th power. And then the -1 that's hanging out in front is still just there. So you could write it like that, or you could do this. -5 to the 11th. Just like they had written that. You can write it that way. I would take this. This is more than likely how you're going to see it in your textbook. Okay? Or on like a multiple choice test or something like that. That's how you normally see it. But this is also correct. Not wrong. Okay? So that negative, if the parentheses are not there, then the negative is not part of the base. That's the thing you got to remember. If the parentheses are there, then that negative is part of the base. If they're not, it is not. Okay? And that's the key part of doing this stuff. Let's go back up here. G, x to the 4th, x to the 6th, x to the 10th. There's 3 of them there. Is the rule still the same? Yes. We're still multiplying them all together. They all still have what is the base? X. So we're adding 6, 4, and 10 together. X to the 20th. And that's it. Very, very simple idea. If we had more of them, maybe we had x to the 3rd times y to the 4th times x to the 5th times y to the 7th. Which ones go together? The y's go with the y's, the x's go with the x's, right? Because those are the ones with the same base. So what does the x end up being? Y to the 11. Good. And really, it doesn't matter which one you put first, but most of the time you're going to see them in alphabetical order at the end. X, then Y. That's normal way of doing that. It doesn't necessarily have to be that way, but that's normally how they do it. Okay. So if there's more than one letter, still look for the same basis and put those together, just like you would like terms when you add and subtract pieces. All right. Pretty easy thing. Okay. So product of a product is multiplying, and you add the exponents. That's the rule. Pretty easy thing to do. Okay. Let's get to the next property. It's a power of powers. Sounds like something, a cartoon or something. Power of powers. This one involves parentheses, and you have a power inside the parentheses. You got a base and an exponent on the inside of the parentheses, and then you have an exponent outside of the parentheses as well. So when you're dealing with the power of powers, you've got this raised to another power. The rule is you multiply the exponents. That's all you got to do. It's just multiplying exponents. So that would be a to the m times n. So if we had an example, x to the third in parentheses, and let's put that to the fourth power. Will it always be x? No, it could be any base. It doesn't matter what the base is there. I'm just using x. We'll do some different letters in just a second. So x to the how much? 12. Yeah, 3 times 4 is 12. If you had something like n to the fourth to the sixth power, different base, n to the 24th, just by multiplying the 6 and the 4 together. All right, so this is where it starts looking a little confusing, but it's not that bad as long as you remember what the base is. So one of the key things to doing these exponent rules and properties is identifying the base of the problem. What's the base in this problem? -6, because it's in parentheses. So that makes the negative part of the base. Okay? So that means the base is going to be part of my answer, right? So parentheses with a -6 in it is part of my answer. What's the exponent on that? Well, it's 2 on the inside here, but brackets are the same thing as what? Parentheses. Mathematically, they work the same. They look a little different, but they work the same way. So if that's a power and it's got an exponent on the outside, what do I do with the 5 and the 2? Multiply them. So it should be -6 to the 10 power. We're going to leave that in exponential form there. Because -6 to the 10th power is a fairly large number, relatively speaking. Be a good amount of money to have in your bank account. This is where that concept of what's the base is important. What's the base in this problem? Why x plus 2 and not just x? Because it's in parentheses. Just like up here, this was in parentheses, and that made the -6 the base. This right here, the x plus 2 is all in parentheses. That makes it the base of the inside here. And it's got a 6 power. And then that's in brackets and has a 3rd power outside. So the base is x plus 2. What's the new exponent? 18. 6 times 3. Okay. No, don't do anything with that. Later on in the first part of chapter 9, we'll do some stuff with that. But right now, no, just leave it. We're just doing the exponent rules in this chapter. Okay. And I don't think I'd ever ask you to multiply out x plus 2 to the 18th power. That would take a few pieces of paper. I mean, it'd be just a really long problem. It's doable, but it's really long. So if you had this problem, bracket, parentheses, 2x minus 3, raised to the 5th power, close the bracket, raised to the 7th power. What's the base in this problem? The 2x minus 3, that stuff that's in parentheses. What's the new exponent? How'd you get that? 5 times 7. You multiply those two exponents together to get 35. And that's it. You're going to stop right there, leave it in exponential form for sure. Oh, yeah, it would be a monstrous problem. Taking it step at a time, you could do it, but it would take you quite a while to do. I promise you that. Okay. All right. So power of a power, multiply the exponents. Okay. The next property that we're going to talk about uses the same idea. It's just getting more stuff inside of the parentheses to start with. Okay. So it's called the product power of a product. Power of a product. And these have names, but I'm not going to give you a quiz on what's the name of this property. I'm not going to do that to you. I'll let them do that to you in geometry. I'm not going to do it to you in algebra because I just need you to know how to do the exponents. The way the power of a product works is you got more stuff in the parentheses. So you got maybe you got a to the m and b to the n, and all that's raised to the x power. Okay, so you got more things inside the parentheses than you had before. If it were just, if I covered up this b to the n and it was just that, what do you do with the m and the x? You multiply them. If it were just that, with the b to the n to the x, you would multiply them. What's going on between these two inside? They're multiplying, right? All right, I can't put these two together because they're different bases, right? But I can put these exponents together the same way y'all said to do it. You said, oh, if I covered up this one, it'd be m times x. And if I covered up this one, it'd be n times x. It's like distributive property is really what it's like. So it ends up being a to the mx times b to the nx. It's easier to see when we put numbers in it. We'll do a problem with the numbers in it. X squared y to the 4th to the 5th. Different bases here, so we can't put those together, but they're both multiplied together with an exponent on the outside. So that means I can say 5 times 2 and 4 times 5 and get x to the 10, y to the 20. And we're done. Okay. If you had more stuff in there, maybe you throw a number in there. 2, x to the 3rd, y to the 2nd, all to the 4th power. What's the exponent on the 2? What's the exponent on the 2? There's how much? There's not one there, but it's 1. Here's what you got to realize. What are the bases that are on the inside? 2 is a base, x is a base, y is a base. There's 3 bases there. So that means you're going to have to multiply this 4 that's on the outside to 3 different exponents. That's, again, it goes back to you've got to recognize what your bases are in the problem. Okay? And this one we have 3 bases, 2, x, and y. So 2 and to the 1st power, 1 times 4 would be 2 to the 4th. X would be x to the 4 times 3, 12, y would be 8. That's exponential form. If I ask, this is for exponential form. What about standard form? What part gets worked out if it's in if I'm asking for it in standard form? 2 to the 4th power. It's the only thing we can work out because we don't know what x and y are. What's 2 to the 4th power? Okay, it's 2 times 2 times 2 times 2. It's 4 of them. 2 times 2 is 4. Times 2 is 8. Times another 2 is 16. That would be if I ask you to write it in standard form. They're equivalent. This is exponential. This is standard. But know that they're the same answer, depending on what form I ask for. Is what we want to go for there. Okay. Let's do one more of those. Let's say we had negative 6 x y to the 3rd to the 2nd power. We can get too big here, but okay. So the first thing we need to recognize is what are the bases that we have inside of those parentheses. Negative 6, an x, and a y. So what's the exponent on the negative 6? 1. What's the exponent on the x? Okay, exponent on the y? 3. Okay, so then it's just distributive property with the exponent that's outside. So we end up with negative 6 squared, x squared, y to the 6th. Why did I put negative 6 in parentheses? Well, if we're calling negative 6 a base and the negative is part of the base, then we have to put it in parentheses there. That's I guess the reason I want to do this example here is because if you're going to use a negative number as your base, then you need to put parentheses around that negative number. That's definitely a good rule of thumb for especially this section and the next 2 or 3 sections that we're doing exponent rules in. Negative numbers with exponents really go a little bit crazy because the reason, well, let's go ahead and work this out and then we'll go into the reason. In standard form, what would that be? What's negative 6 squared? Positive 36. So there's standard form. This would be exponential form. Okay. The reason that you want to be careful with those negatives and have them in parentheses is because if I had negative 4 squared and then I had negative 4 squared, these are not the same problem. They do not give the same result. You could type it into a calculator and it would tell you different answers. Okay, if you did type it incorrectly. Okay, this one, the negative is not part of the base, so we're squaring 4 and then making that answer negative. So this one has an answer of negative 16. But what's squaring negative 4 do? It's negative 4 times negative 4. Negative times a negative is a positive. So this is positive 16. That's where the parentheses are very important when you have a negative number as the base. Or if you don't have a negative number as the base, the parentheses are not being there is just as important. You've got to be careful of that in this stuff. It only comes up every few problems, once every 5th problem or so. It's not all the time, but a good 20% of the time that you need to be paying attention to that stuff. So we've got to look for that on every problem. Okay. All right. Last thing in this section is this kind of obscure thing that you'll see in this section and this section alone. You probably won't see it again in this course. It's called order of magnitude. It's really easy to do. I saved it for last. Order of magnitude. Okay, order of magnitude is the power of 10 nearest the number. Okay, now when you talk about magnitude, one of the first things that jumps into your mind when you say magnitude, in my mind, is an earthquake. Is that that word doesn't get used much? Is an earthquake has a magnitude of a certain amount. What the magnitude of an earthquake is basically based on readings that you get on seismic activity and how far the needle moves and how much the earth has been moving. That's how that's done. But the magnitude of it is based on a base 10 type situation. And this is used more or less to estimate and compare numbers, not necessarily to get exact answers. When we're talking about order of magnitude, we're just kind of getting an estimate about where we're at in the number system. Okay. So what are the powers of 10? Well, 10 to the 0. How much is 10 to the 0? Does anybody know? No. 1. Anything to the 0 power is 1, always. That's a definition rule. 10 to the first power would just be 10, right? What's 10 squared? Nope. That's 10 times 2. 10 times 10 is 100. What's 10 cubed? 10 times 10 times 10 should be 100 times 10, which is 1,000. 10 to the 4th, 10,000. 10 to the 5th, 100,000. 10 to the 6th, 1 million. Exactly. You just continue that pattern there. That's the powers of 10. What we're going to do is we're going to compare the number that they give us to which one of these is it closest to. And that's what we're going to get for a magnitude. Okay. So if I had, for example, I don't know what number letter we're on. Q. For example, I had the number 1,216. Just a random number. Which one of those is that closest to? 1,000. It's closer to 1,000 than it is to 10,000. So its order of magnitude would be 10 to the third. If we're asked to find the order of magnitude, we're just trying to see what number is this closest to on the powers of 10. Okay? If I had the number 1,000, or let's see, let's do 9,568. That's close to 10,000, right? Which is 10 to the 4th. The order of magnitude is the power of 10. Don't give me 10,000, give me 10 to the 4th. Don't tell me 1 million, say it's 10 to the 6th. Out of that, okay? If I had that's 8 million, right? 8,672,366. It'd be closer to a billion than it would be to 1 million, right? So that'd be 10 to the 7th. Closer to 10 million, sorry, not billion. Yeah, 10 million. Yeah, would be the right word. If it were 2 million and something, what would that be closer to? 1 million. Okay, it's kind of like that rounding rule where it's 5 or bigger, you go up. That's the same rule you're going to use here for order of magnitude. We're just looking for which power of 10 is this close to. So when you get to those problems, there's not many of them. Make you a list of powers of 10. You've already got one in your notes there started. Just go ahead and continue it if you need to. And get your powers of 10. And then just estimate what number is it closest to. That's all there is to the order of magnitude problem. Nothing else to it. Okay. All right. Pretty easy start to the 9 weeks. Your practice for today is on page 492. What's up? Yeah, get to pass them. Yeah, it is. All right, here's your assignment for today. On 3 through 18, do exponential form. So that means don't work out the number. Just get it like 3 to the 5th power, leave it that. And then on 19 through 38, that's the biggest bulk of these. The standard form is what we're looking for. So if it's 2 to the 3rd, make it 8. Work out the number on 19 through 38. When you get to these, it'll tell you what to do. There are a couple of those are word problems, the others are order of magnitude problems. So it'll tell you what to do with those, and you'll know what's going on. All right.